So we are looking at section 4.5 and part A, so exponential and logarithmic equations. So in this section we will learn how to solve exponential equation, and then in the part B we will learn how to solve some logarithmic equation, and then in 4.5C we will look at more logarithmic equations and exponential equation. Okay, so we remember an exponential equation is an equation in which an exponential function is present. So guidelines for solving the exponential equations: if you have this situation, the first thing is to isolate the exponential term. So if it is already isolated, then first step is done. And then since the variable in exponential equations will be in the exponent, so we want to bring it down. So there are two ways to do it. One way is to just convert the equation into the logarithmic form, or we can apply logarithm on both sides and take the logarithm of both sides and then go from there by using the properties and the laws of the logarithm. Okay, let's look at this. So first, this example, well, we can do it with the log as mentioned above, but actually this is much simpler to do it with the powers of the same number. So see 16, I mean it will be hard to write 16 as a power of 8 or 8 as a power of 16, but both 8 and 16 can be written as powers of 2. So this can be written as power of 2 as 2 to the 4 whole raised to the power 2x equals, so 8 remember is 2 cubed, so 1 over 8 will be 2 to the negative 3. So left side we don't have it as a true power of 2, so we multiply the powers and get 2 to the 8x, and now we have it left hand side as a power of 2 and then right hand side as power of 2. When the bases are the same, now we will apply this kind of property, this result from by the function exponential function being a one-to-one function. So when bases are same, powers will be the same. So we get 8x equals negative 3, which means x equals negative 3 over 8. Okay, looking at the next example, well, here we have e and 9, so we cannot write them we cannot do it like the way I did a. So what should we do? Well, the exponent in the exponent we have the variable 3x, so base here is e. So what we will do, I will apply ln. I get ln e to the 3x equals ln of 9. Now what is ln of 9? We don't know. We can, only way we can know is by using the calculator, but calculator is not allowed. So you have to think of what should we do next, because remember our goal is to get x, so unless and until we get the x down, bring it down from the power, we cannot do anything. So this applying log helps us do that, because now we can use the rule of logarithms, the power rule. So I can write 3x times ln of e equals ln of 9, but ln of e is 1, the property of logarithm, so I get 3x is equal to ln of 9, so that x is 1 over 3 ln of 9. Now this is called the exact value, and in the exams you are expected to leave the answer in this form, because otherwise how can you get the value or simplify? You have to take the calculator. So no calculator here. Okay, the other way you could think of it is convert it into the logarithmic form. So remember, this is base, e is e to the 3x is equal to 9. So if you convert it to the logarithmic form, it will be ln, because log base e of 9 equals (3x). So x equals 1 over 3 ln of 9. So same thing. Okay, but in the same way, this we can write, if we use the direct base thing, so converting it into logarithmic form will give me log base 3 of 5 equals 3 raised to the power 2x minus 1, and so the 2x minus 1, not 3 is used in the base. Okay, so log of 5 base 3 equals 2x minus 1. So then I will add 1 to both sides, so I'll get 1 plus log base 3 of 5 equals 2x. Then I can divide by 1 by 2 or multiply by 1/2 and get my x. So, but it is recommended up there, see, for exponential expression uses base e, then use the natural logarithm. For any other base, use log. So they are saying don't do this, don't use this, use log. So which means I am going to apply log to both sides. So the left hand side I use the power rule. Okay, so now remember we have to get 2x minus 1. So I will divide by log of 3. Now note here, the log and the log don't get cancelled. Then we do our little algebra here. Add 2 to both sides. Sorry, add 1 to both sides. Now divide by 2. So this term, this thing remain as it is. Okay, you do not need to make any changes or simplify it. You cannot apply any laws of logarithm. That is your answer. Okay, looking at the next example, can you see now here this exponential term is not isolated, so we can do it in two different ways. So this 4 is outside this whole thing, so we can divide by 4 on both sides, and we get 1 plus 10 raised to the power 5x equals 9 over 4. So then I subtract 1 from both sides, so I get 10 to the 5x equals 9 over 4 minus 1, or 10 to the 5x equals 5 over 4. And from here now you can do the converting to the logarithmic form, or you can say taking log on both sides. So log 10 to the 5x will be equal to log of 5 over 4. So now this will give me 5x times log of 10 will be equal to log of 5 over 4. So then I have to get the x from here. So I have to divide by 5 times log of 10. Do I need to divide by log of 10? Think about it. What is log of 10? What is the value of log of 10? This is 1. So I have now 5x equals log of 5 over 4. So x will be equal to log of 5 over 4, whole thing divided by 5, or you can put the 1 over 5 here. Now sometimes the answer is written like this. So this one we can write log of 5 minus log of 4. That could be your final answer. Okay, same thing here. Now we have on both sides we have exponential function. So which log should I take? Log base 7, log base 5, or what? So remember, we are recommended to do LOG when we have bases which are different than 10 or E. Basically different from E, we take LOG. So LOG 7 raised to x over 2 will be equal to LOG 5 raised to 2 minus x. So now we apply the law of one of the laws of logarithms, and we see that from on both sides we are going to get the power down here. Log of 7 equals 2 minus x. Now I have to keep it in parentheses because these are two terms. So now remember, here when we say log, the base is 10. Okay, now you have to try to simplify it. How will we do it? Well, now this is not becoming 1 or this is not becoming 1. They will stay as they are. So on the left side you have, so we have a 2 at the bottom here, so we could multiply the whole equation by 2. So we get x times log of 7 equals 2, which we can multiply in here. So we get 4 minus 2x times log of 3. So now again simplify, and maybe if you have to distribute things, or because we have to get any term which has x, we have to combine them or get them in the one side of the equation. So when I distribute, I get on the right hand side 4 log 3 minus 2x log 3, or 2 log 3 times x. So now see, this term has x and this term has x. So I will bring this term on this side. So I get x log 7 plus 2x log 3 equals 4 log 3. So 4 log 3 does not have any x in here, so it will stay on the right hand side. So I now can factor out the x from here. So that x will be equal to so if you want to write it as log of 9, that is fine. That will be your answer. So we leave the answer in this form because otherwise we need calculator. So and there is no formula that will make it simplified. So this is how we solve these exponential equations. So remember when we were doing the graphing the exponential function, I mentioned that you cannot find the x-intercepts because we have to learn some more solving the equations, exponential equations, and you can do the finding the x-intercepts, or y is easy, x-intercept specifically. Now you can. Okay, in the next video we will look at 4.5b, which is going to be for solving logarithmic equations.